Time for an easy little exercise. Behold the square ABCD. Let's call the length of a side of it A. Using a radius of half the length of the square side, let's trace two circle arcs limited by the square using two opposing corner points of the square as center points. Take, for instance, B and D. The intersection points of the quarter circle from B with the square are E and F, and likewise the intersection points of the quarter circle from D with the square are G and H. Now consider X to be the point in the middle of the square. We will use X as center point and we will trace two circular arcs with radius half the length of the square side that will fill the gaps between F and G on the one hand and H and E on the other hand. The curve obtained this way somehow looks like the head of a double-bladed battle axe, or do I have too much fantasy? What is now the area of the battle axe? Let's draw the lines HF and EG. AEXH is a quarter of the square, and so the area of this little square, let's call it O, is A squared over 4. We will call the area of one of the quarter circles P, and the value P is, using the formula for the area of a circle, a quarter times pi times the radius squared. The radius is here A over 2. Simplifying, the area is 1/16 times pi times A squared. The total area of the battle axe is 2 times the area of a quarter circle with center point in X, plus 2 times the area of a quarter square minus 2 times the area of the quarter circle with center points in B and D. We can conclude now that the area of the battle axe is half the area of the square, and that is a nice result in my opinion. Well, that's it for this time. Thanks for watching. I hope you found this video enjoyable, and while I cannot promise a regular release schedule at all, it would be wonderful if you could subscribe and share.